us off, our next presentation is Dr. Thomas Coolbaugh from Ohmsett, talking about updates on capabilities, focus areas, and recent projects. Tom, good to see your face there. Tom works for Applied Research Associates as the program facility manager of the Onset Wave Test Tank in Leonardo, New Jersey. He recently retired from ExxonMobil after 32 years, where he was the technology and advocacy advisor for the Emergency Preparedness and Response Organization. Tom, we're happy to have you here. Take it away.
All right, so let me see if I can share. Is it set? So I think I have to do. So hopefully you can see that.
I'm waiting for it to come up.
Okay. Oh, there. All right, let's see. I'm trying.
All right. Not to worry, we're ahead of schedule.
I'm clicking on the share button. And it's not doing anything.
Oh, something's coming up. There we go.
Hopefully. Oh, there it is. Okay. Thank you.
Yep.
Yeah, as you said, I spent 32 years with ExxonMobil and moved over here after retiring in July. So I'm the program and facility manager at Onset. I've actually been coming here for the last 13 or 14 years in my role of oil spill response. So it was an easy transition. It's a great place to be. And this is a chance to sort of talk about it. As Karen indicated, there are a number of things that different organizations, BSEE in particular, have spent a lot of time here doing different projects over the years. Recognize some of the things there that my ExxonMobil colleagues have worked on, whether it's the burning tongue or the jet ski. It's a fun place to be. To me, it gets me back into some of my sort of the research background. I'm a research chemist by training, and it's just one of those things you come into work and it's a different thing every day. So from that standpoint, I like it a lot. So I'm just going to give an overview on some of the things that are here, the things that we're looking at, what we've been working on recently, and some of our future plans. Again, as Karen indicated, there are some things down the road that we're looking at that are fairly significant and I think can hopefully add value to the oil spill response technical community. And we'll certainly look forward to any input from different potential users. Now, let me see if I can figure out how to move this down. That may be my next challenge. Okay, so just an overview. We'll talk a little bit about the tank, some of the specialties that are here, and again, things that we have done and the things that we do. The one thing I've noticed over the years of going to different oil spill response conferences is that whether it's the Clean Gulf Conference, the International Oil Spill Conference, Interspill, or others, is you see a lot of pictures of the Onset tank because it's kind of unique. It does have some capabilities that you can't find in too many other places. As it says, the largest outdoor saltwater test tank in North America, 203 meters long, 20 meters wide, 2.5 meters deep. It's easy to remember how much water's in it because it's 10 million liters, which is pretty significant. We can do waves up to about a meter. And the salinity is meant to be open ocean, so somewhere in that 32 to 33 thereabouts parts per thousand. We actually get the water from Raritan Bay. We sit here right on Raritan Bay. I look over at New York City, but it's fairly brackish because of the river flow that comes into it. So we actually have to add salt to it to bring it up from about the high teens or 20 parts per thousand up to the 30s. And to give you an idea for that, last fall, we actually had to raise the salinity because of a lot of rain that we get. This is actually a containment basin in some ways where rain runoff makes its way into the tank. We can't just discharge it. But the salinity had gotten low enough that we had to raise it about 10 parts per thousand. And just to get an idea, that took 110, 120,000 pounds of salt to get it up to that kind of a scale. So, or kilograms, I'm sorry. It was 100 metric tons that we had to put in. But that's just the kind of scale. For every inch of rainwater we get, that's about 25,000 gallons. So it's a large tank. The advantage is it's outside, so you get real world conditions. The downside is it's an outdoor tank and you get real world conditions. Right now, it's actually snowing here in northern New Jersey or central New Jersey again. As Karen indicated, we did do some work recently on making ice and doing some ice-based testing. I'll show you a couple of pictures of those. We have a computer-generated wave, computer-controlled wave generator. We're actually doing some upgrades on that, but we can control pretty carefully, whether it's sinusoidal waves, at least for the first few minutes, or we can deliver a braking wave in a particular location. In fact, some of the work that was done recently around the dispersant effectiveness test was really kind of neat, that we could, working with Alan Guarino and the other, the SL Ross folks, we could get a wave delivered right in a particular spot where we're looking at dispersant activity. So that was really pretty interesting to see. As it says, we're an hour south of New York City, 35 miles from Newark Airport. That's actually the closest airport, but it's relatively convenient to get to. The difficulty sometimes is that we're in the middle of a naval weapons station. So clearances to get in take a little bit of time. So we just need to plan accordingly when we have clients coming to visit. As it says, it's operated by BSEE as part of the Department of Interior's operations, and I work very closely with people like Christy and Karen and Jay, and I've known Eric Miller for quite a while. Gina Coelho I've known for quite a while too, so we're excited to have, again, working with the BSEE team. In the past, again, as indicated, we do all of the different spill response tools, whether it's mechanical recovery, chemicals such as dispersants or herders, looking at other things, looking at the fate and effects, what kind of droplet size distributions do we make? We actually have equipment to help measure that. We have a laser light scattering detector so we can get the droplet size distribution. We also have fluorescence detectors. We do things, as it says, with dispersed or weathered oils, but also emulsions. And working with Karen and the BSEE crew, there's been quite a bit of work on that. We actually have a group here working today talking about the refurbishment that Karen indicated that we're going to shut down this coming summer. So I was just told that it's lunchtime, but I'm here talking to you guys. We do a lot of work on sorbents, wave energy converters, again, trying to get beyond what I would say is the typical oil spill response toolbox, looking at renewable energy, what other things can we do? And I think there's some indications in some of the slides that are coming up. You can put different sorts of, whether it's autonomous or remote vehicles in there. Rotary and fixed wing aircraft, certainly we've had overflights to see different thickness measurements and other things along that line. We'd like to get to the point where we can actually start doing the drone type measurements again, but because of where we are, there's some controls around that. So it's a little bit difficult, but we do have a crow's nest. We have a tower where we can take aerial photographs pretty effectively. Oil handling, we deal with a large amount of oil on a fairly regular basis. And then things like mechanical debris, whether you're using booms for oil, that's one thing. But now we look at some tests that are being done around plastics recovery. And sometimes it's the ability, how do you get that solid material out once you've collected it? And I think there's some interesting challenges on that going forward around the world, really. Oil spills, fortunately, are relatively infrequent. Plastics in the ocean are a much more constant thing that needs to be looked at. It, certainly point control, source control is one thing, but once it gets into the open ocean, what can actually be done around that? And that's something we're looking at as we go forward also. Skimming systems, there have been a lot of tests done here over the years, whether it was looking at skimmer efficiencies, new kinds of skimmers, what else can we do to improve what we have, whether it's in ice. Again, having an open water tank certainly gives you that capability to really look at it. So you really can put a fair amount of oil on the water, and we have the capability of removing it as well, whether it's through the skimming. Even when we disperse it, we have a fairly robust filtration process that can clean the water back up reasonably quickly. Other things that have been done are harbor security and other studies, whether it's looking at booms to block some sort of a motorboat, speedboat from getting into areas where it shouldn't be. They've actually run full-size boats down the tank into different barriers. I've seen the video of that. It'd be kind of neat to be here for that, because certainly most of what my focus has been around oil spill response. As it says, towing up to 6 knots, so this is a tow tank. It doesn't have much of a current, but we can drag something through the water up to that kind of speed. So if we're looking at boom containment failure, we can look at different improved procedures for making booms more effective in high speeds. Granted, when you go down 200 meters worth of tank at 6 knots, you get there pretty quickly. But if we do the half knot, 3/4 knot, a knot and a half, we can do a lot of studies that at least mimic what the open ocean, sometimes flowing water conditions might look like. Sensors, we do have a number of sensors, both looking at the surface of the water, but also under the water. There's been work recently around the thickness characterization of oil slicks. That to me is one of the holy grails. If you could tell me where that thick oil is so that equipment and personnel can be deployed most effectively in the case of an oil spill response, that to me is really pretty significant. Because just knowing something's a half a millimeter thick is one thing, but if you can distinguish that half a millimeter from a 3 or 4 or 5 millimeter thick slick, that is very significant. The crow's nest there, again, we have a camera mounted up there. We can mount other things, whether it's GoPro cameras or other things that sensor. The yellow one that you see there in the central picture, that's using acoustics to be able to measure where the water surface is. So we can get a wave profile fairly effectively from that. And then we have turbulence meters. So again, we can understand what kind of energy is present in the water as we generate waves. Again, deploying real world equipment, either looking at hydrodynamics, looking at how things, whether their robustness is in the open ocean, looking at things like mapping, it says ocean floor mapping, but looking through the water column, whether it's with lasers, acoustics, it says UUVs, which is not the normal term that I get, but that's really anything that's an unmanned underwater vehicle. So whether it's an AUV or something, an ROV, to me, those are all part of the same technologies. It's just the question is it remote? Does it work autonomously? But certainly being able to deploy it in this tank is pretty significant. And we have done a couple of studies where there's been an oil slick and we could put the camera or other sensor under it, or as in some of the other tests, in fact, I'll show you this in the next one, where dispersants were being delivered subsurface. You could actually put an ROV under there with acoustic sensors or optical sensors to really see what's going on. Plus we have windows on the side of the tank, so you can see things much more clearly that way too. But other things that have been looked at over the last few, actually some of these are recently, just in the last few months or so. That upper left one with the purple color, that was this, it's the MPRI, so the Multi-Partner Research Initiative from Canada, but working with NOAA, BSEE, Department of Fisheries and Oceans, Coast Guard, and EPA. They were looking at different sensors for measuring slick thickness, and in particular looking at a fixed area, how uniform is a slick? Because typically out in the open ocean, they aren't uniform. They have thick parts, they have thin parts, and part of what that's looking at is how to, once you've determined it, what kind of equipment do we have that can really then measure it when we know what it is? You can make something that's a millimeter thick, and then you can test the instrumentation to see how well that works. Oil slicks and emulsion studies, again, looking at remote sensing. Large-scale emulsion, working with BSEE in the past. There's a lot of work that's been done on making stable emulsions, and I think that's something that can have some real value, because as indicated, sometimes having emulsion in an in-situ burn can actually work more effectively than not having any water concentration. So having something that can be well-defined is a good tool to be able to do. Dispersant studies, again, that's been my focus area over the last 13 or 14 years, both surface and subsurface. A lot of attention after the Macondo spill, and it still is going on. So the projects that have been working through, whether it's IPCA or the API, IOGP, other multi-partner initiatives, JIPs, it continues to be an area that is still somewhat controversial, but there's been a lot of work done here in the water at the Onset Tank to help understand that. Along with actually doing the scientific part, one of the key values that the Onset facility has is that you can actually do hands-on work. So you can actually put oil in the water, whether it's in a fast tank, like in that picture on the right, or actually in the tank and then generate waves. So whether it's the Coast Guard, whether it's industry, whether it's other training programs, it gives you a real feel for I'll say the challenges, the difficulties of doing it well. It's easy to collect lots of liquid when you run a skimmer. The challenge is being able to make most of that liquid oil. So at least doing some testing under these kind of conditions, I think gives the response community the opportunity to test in such a way that there's more of an appreciation of the kind of challenges that can be faced in deploying something, and then trying to understand why one of the tools might be better than another depending on the conditions that you're in. So we continue to do that. There's been some challenge certainly over the last year in the world of COVID-19. And we're hoping that by the fall, we can really get back up to speed on the kind of things around training in a hands-on setting. With that in mind, let me just talk a little bit about the future here. So as mentioned, the tank will be shut down this coming summer. It's something that's done every 5 or 6 years. It's time to just drain it. This only gets drained, again, maybe every 5 or 6 years. It's not a trivial thing to drain 10 million liters of water. We actually have to clean it more or less beyond the cleanliness of the water that we're going to dump it into in Raritan Bay. We'll just discharge it back out, but it will go through a very stringent cleaning process before that happens. But as Karen indicated, a goal is to, first of all, clean up the tank. We'll fix all any concrete surface areas that need to be fixed. We'll redo the paint. We're looking at taking the beach out, and there's a project that's currently undergoing to design a beach that does have better control characteristics with respect to reflections. Because if you come here, we can start generating waves, sinusoidal, and they last for a few minutes, but ultimately you start getting reflections coming back from the other end of the tank. And you start getting into a fairly chaotic condition that I'll call harbor chop within several minutes, which means that if we want to have very controlled wave conditions, we need to shut down the wave controller, let it calm down, and then we can start it again. So that is a project that has been ongoing for several months, and we look forward to a fairly interesting time of seeing how we can update and upgrade what we have. The other things that we'll do is certainly we're just looking at corrosion and other things. This is a salt air environment, so it does get kind of rusty in some places. If you've been here, we have what are called the movable bridges that are steel, and they need to be maintained from time to time. And that's a major part of what this tank refurbishment will be. And we're just going to try to make it better than it was, and we'll continue to make sure that it stays in good condition for anybody who wants to come and use this. Measurement protocols for dispersant effectiveness. Again, Karen mentioned that, trying to update the kind of tests that have been done here over the last 20 years. I've been here several times where we did the dispersant tests on the surface, and we can collect it, but this is a much more precise measurement of how effective dispersant use is in this kind of an environment. We're looking at what other kind of cameras, what other sensors we can have above and below. We're looking at integrated video collection systems, because really what we're trying to do is, for those of you who can't come here for one reason or another, whether it's because of travel restrictions, whether it's budgetary, whether you've got a team that's extended, we're trying to make sure that we have the video, audio, other capabilities to at least provide the sort of real-time presence, even if you're not here. So that's an ongoing thing that has really been a major focus for us for the last 6 or 8 months. As also mentioned, the upgrade on the flume tank, we're looking at something along the line of 60 feet long. I'd like to put it in one end of the building that I'm in, and we can really then vary lots of different conditions. But the one thing that is very unique about this facility is, as Karen mentioned, we could take water from the big tank, put it in a smaller tank, do whatever we would want with it. And ultimately, when we're done, whether it's been made colder or whether it's been exposed to different conditions with oil in it or not, then we can just dump it back into the big tank where it can be processed normally. So it's a very integrated system that not too many places have that capability. I would also like to be able to make it freshwater, saltwater. The tank outside right now is chlorinated, so there is no microbial work that can be done there. But if we do a smaller tank, we could also use non-chlorinated water, so that the academic community or others could really look at microbial biodegradation in a more lifelike, more real world situation. So I'm pretty excited about that. I've been working on a proposal, or at least a description of the kind of things that we're thinking about, as well as expanding our testing capability in the laboratory. That includes the footprint where we're currently located, but also looking at, can we expand the space and try to at least include things that I'll say the industry, but just potential clients would be very interested in. And that's where I would ask anybody who's listening, if you do have ideas of what you think would be of value to you in this kind of a facility, just let us know, because we're really doing a pretty broad overview of what we think we should be thinking, or at least focusing on, again, going forward, beyond just oil spill response, realizing that that's still our primary goal, but are there other things we can do? Modern bridge, we're just looking to upgrade our equipment along that line too. This is the bridge that moves up and down the tank. And then, as I stressed, that enhanced customer facilities with a focus on health, safety, and remote connectivity, because I do think that we are hopefully moving beyond COVID-19, but it's going to be with us for a long enough time that we need to make sure that we can address concerns, whatever they might be. Again, whether it's budgetary, whether it's health-related, safety, we want to make sure we do things right for people who might visit here. So we do have the capability to do social distancing. We have an enhanced capability to disinfect, and we will keep doing that. the last thing I really want to end up with is just showing you a couple of things that we did just in the last month or so. And again, as Karen indicated, we do some work with ice. It got very cold here during January, but at the same time, there was a project around an ice management system that was really looking at cleaning ice that was oil contaminated. So we had a chiller that was large enough that we chilled the tank itself down to about 30 degrees Fahrenheit. Saltwater freezes around 28 or so, but we got it cold enough that it didn't quite freeze. But then we also made on the order of 100,000 pounds of freshwater ice to put in there during some of the testing that BSEE was doing. Then the weather got cold enough that the salt water actually did start to freeze. So there are a couple pictures there, that one in the middle in particular, that is saltwater ice. It's very kind of slushy, it's very pliable. It's not multi-year ice, but it's the first time I've ever seen this facility frozen. And you can see some other pictures there. That it was a kind of a wintry place to work, which people who work here understand that. So that's one of the good things and the bad things. You know, whatever the weather is doing, we still do whatever we do. We had a large crane that came in, and there's a piece of equipment that is called the bowhead that was put in. And that was really looking at that bottom left-hand picture of an oil-covered 500-pound block of ice that got pulled up, rinsed off, and then put back into the tank. So it was really pretty amazing to watch. The picture right in the bottom center is the piece of equipment after we had a snowy day. So the crew was actually spending the time, in that case with a bobcat, to clean the walkway because, again, we had snow and we also had people here doing work. And then you can see a picture there of some trays. Those are actually trays of ice that were in refrigerated units that were cooled down to 0 degrees Fahrenheit, again, to provide that 100,000 pounds of ice or so that was used. And I'll just end up with my contact information and Jane Delgado, who does a lot of work with us, updating our LinkedIn page and trying to at least inform everybody what's going on. My goal was to get to 500 followers on LinkedIn, and we're 508 now. So we've been moving upwards, and we just want to make sure people know who we are, what we do, and hopefully come and do some work here. It's a fun place for me to actually be here. So I'll end with that.
Thanks, Tom. Yeah, that's great stuff. And I knew when I heard you were going there, it was going to be a good fit for you and a good fit for Onset. So I'm glad you're there. Jenna, Lindsay, do we have any questions?
Yes, we have one question.
Sure.
How has COVID-19 affected scheduling and testing in the wave tank? And are there remote testing options?
Sure. Actually, that's such a key part because it has affected the schedule very significantly. Again, because of travel restrictions and quarantines and all that. But again, we have the capability of putting people in a conference room where we can be 6 feet apart. We make sure that everybody is required to wear masks. We do a daily deep cleaning, and this is stuff that BSEE has funded us for. The main thing then about at least providing that remote connectivity, we can do nearly real time, and there have been a couple times where somebody from Johns Hopkins couldn't make it. Nancy Kinner was hopefully going to be here last January, December, couldn't make it. So at least we could tie into the University of New Hampshire and Johns Hopkins. So at least we did do the sort of the debriefs at the end of the day, talked about what was going on at the beginning of the day. We had one person or a couple people here, whether it's from SL Ross or others, actually doing the test. But we try to document it with high quality video, photographs. And so at least we can do the best we can to make sure that even if you can't make it, we can help convey the work that's been done. And for me, a real goal is to hopefully become an international global thing where it doesn't matter where you are on a time scale, a time zone either. That if you're in Singapore, I'd still like to be able to do that remotely. We'll figure out how to do it with the time zones. But we still need to upgrade some of our camera technology. And again, if people have an idea of what is important to them, that's something that we're putting proposals together for BSEE at this time. Because again, I think that's going to be the path forward again, whether it's budgetary or health related. That's sort of the new world. And I think we're capable of doing it. From my standpoint, I hope that we can convey the technical capability. We have a very high quality staff who can make almost anything. I've been with this facility now for about 7 or 8 months, but again, I know it from the last 13 or 14 years, and I know the science and technology of oil spill response. So I think we can actually design a testing protocol or program that anybody would want or could potentially need without necessarily feeling the need to be here. I just want to have that comfort level that at least get to that point where people do feel comfortable with that.